Hello everyone, this is Divyank Khandelwal and today we're going to do the revision of circular measure of additional mathematics 606. Now this topic will be useful for math HL as well as SL, but I'll take past papers only of add math 606. So we're going to do that. Anyway, so the topic is divided into three parts. The first one is radian degree conversion, the second one is length of arc, and the third is area of sector. So we're going to start with this thing called 1 radian. Now what is 1 radian? Now supposingly if I have a circle of radius r and if I cut a length of arc of radius r centimeter like this, then whatever the angle which is going to be subtended by this arc is going to be 1 radian. Okay, now if I extend the circle's radius like this, for example, then it's going to be a huge circle, somewhat like this. Okay, but the length of arc is also going to be huge because the radius is huge. But as you can see, the angle which is subtended will always be same. That's why this is known as 1 radian. So traditionally we used to use degrees as our converting unit, not converting unit, as in we used to use for angular measurement. But from now on, we are going to use radian as our conversion unit. So traditionally we used degrees as our measurement for angles, but from now on we are going to use radian as our angular measurement. So anyways, let's move further. So for how to convert this degrees into radians and radians into degrees, so that's what we are going to learn now. Now if I can consider any circle of any radius, so why shouldn't I take circle of radius r is equals to 1, which we generally use in trigonometry as well, the unit circle. So if I do that, then the length of arc which is subtended is going to be also 1 centimeter. So it might be somewhat like this. So now this is going to be our 1 radian. Now this is 1 centimeter, like length of arc. Now if I consider the length of whole arc, or basically the whole circle, that is nothing but your circumference. So we are talking about the circumference. So circumference of this circle is going to be how much? It's going to be 2 pi into r, and here r is equals to 1, that's why it's going to be 2 pi. So the angle subtended is going to be 2 pi radian. And we know that 2 pi radian, like the whole circle, angle is 360 degree. That's why we know that here if we talk about radian, then this is degrees, then 2 pi radian is going to be 360 degree. So in short, pi is nothing but 180 degree. That's the conversion we know. Now to convert radian into degrees or degrees into radian, what we will do, we'll use this thing that pi is equals to 180 degree we know. So basically you can use unitary method or any other method to find out other angles as well. Now for example, if I want to convert 60 degrees into radians, so what I'll do, so here we need to convert 60 degrees into x radians, we will say. Okay, now we know that 180 degree is nothing but pi radian. So therefore, as you can see, we will use this crossing. So we'll get x is equals to 60 into pi by 180, or in fact this is going to be x is equals to pi by 3 radian. Now that's how you will convert degrees into radians. And if I want to convert radian into degrees, then what will happen? If I want to convert radian into degrees, then so for example, let's say 2 pi by 3 radian. So if I have degrees and radians, and this is 2 pi by 3, and this degrees we need to find, and 180 degrees nothing but pi. So again we'll do crossing or whichever method is suitable for you. So that's what we are going to use. So this is going to be what? X is equals to 180 times 2 pi upon 3 pi. So you can cancel this pi, this pi. So this is eventually going to be 120 degrees. Now that's how the calculations are for degree to radian or radian to degree. In short, I'll summarize like this. If I want to convert radian into degrees or degrees into radians, so if I'm converting radian into degrees, then I'll multiply by 180 by pi. And if I want to convert degrees into radians, then I will multiply by pi by 180. Now how to remember this thing? See, radians are generally with respect to pi. So that's why if I have some angle in radians, it has to be something like this, 2 pi by 3 or something like that. So in degrees there is no pi. That's why I'll divide by pi, but I'll multiply by 180. On the other hand, in degrees there is no pi, but in radian there is a pi. So that's why when I'll have to convert it into radians, I will introduce pi. So that's why I'll multiply by pi, but I'll divide by 180. In other words, also you can remember that radians are always smaller and degrees are large. Of course, because if you think about 2 pi radian, this is nothing but 6.28. But if you talk about that thing in degrees, it's going to be 360 degree. So that's going to be the difference. So this is radian degree conversion. So which I saw that there are not many past paper questions based on this thing, but there are questions based on length of arc and area of sector. I'm not going to take the proof. I'm just going to give you the formula directly so that we move on to the past papers. So now length of arc and area of sector. So I hope you know the definitions of area, sector and arc, the difference. Like if this is a circle, then like if this is a slice of pizza, then the crust is basically your length of arc, like this thing. I'll shade it. Okay, I'll have to shade again. Okay, I don't know. So this is going to be your length of arc. But if you talk about area of sector, then the whole thing, like basically this thing is going to be your area of sector. Like the whole slice of the pizza is going to be area of sector. So this is the difference between length of arc and area of sector. Now what is the, now see, I'm going to give you that the formula which we used before. So we know that length of arc is theta upon 360 into 2 pi r. Right? Theta upon 360 into 2 pi r, that we previously learned. But if the angle is in radian, then the formula is simple. If the angle is in radian, the formula is very simple. It's simply r into theta, provided theta is in radians. Okay. Similarly, we know that it was theta upon 360 into pi r square. Here, if the angle is in radian, it's gonna be theta, just half r square into theta radian. Okay. Now, if you want to convert, see now theta is in degrees. So in this formula, theta was in degrees. So if you want, you can to convert that theta into radian, what we do, we multiply by what? We multiply by 180 by pi. If this would have been in radian. So if theta is in radian, so we'll convert it in degrees. So 180 by pi into 2 pi r, whatever it is. So now we can cancel this 180 and 2 with 360, and we can cancel pi with pi. So eventually we'll get theta and r. Same proof you can apply there. So just convert that theta radian into degrees and you get the same formula. Now, without wasting any time, let's start with the past papers now. So this is all you have. So these are the two formulae which we are going to use forever. Acha, also one more formula is there which we are going to use for the triangles. Now, if I have this triangle, and I hope you know the area of triangle when we know this side, and the angle between them, let's say C. So the area of this triangle is going to be half into A into B into sine of angle between them, so sine C. So we're going to use this formula as well. So that's it. That's the end of the chapter. Okay. But now let's start with the past papers. So these are the papers which are quite recent, as you can see, it's from 17 to 20. So 17 to 20 onwards, these are the papers, 17 to 20. So anyways, so generally they give you twisted questions only. So if I have a circle like this, let me give you one basic example. So let's say radius is 10 centimeters and the angle between it is let's say pi by 3 radians. Okay. Now what is going to be the length of arc? So length of arc is going to be r into theta. So it's going to be 10 into pi by 3. So which is nothing but 10 by 3 pi. So you can use calculator for this thing. That's your answer. If you talk about area of sector, it's going to be half into r square into theta. So it's going to be half into radius square is 10 into 10, so 100, or 10 square into pi by 3. So that is nothing but 10 square is 100, 100 by 2 is 50, so 50 pi by 3 radian. So that's your answer for this thing. Of course, centimeter square, meter square, whatever it is. Achha, by any chance, if you get confused with respect to which formula is for what, so remember length of arc is length of arc is length. So the unit for length is centimeters or meters. So that's why there will be only one r. But if you talk about area of sector, so area is generally centimeter square, meter square, something like that. So here it's going to be centimeter square, that's why r square. What is this thing? Oh, sorry. So basically it's going to be half of r square into theta radian. So this was quite basic. Now let's move on to some past paper questions. I figured out some of it. So let's start with this thing. This was asked in November 18. So here they have given you the circle. The diagram shows a circle with center. Can you see it? Yeah, you can. The diagram shows a circle with center O and radius r centimeter. The minor arc AB is such that, like minor arc, like this one AB is such that angle AOB is in theta radians. The area of the minor sector is given AOB, that is 48 centimeters. Show that theta is 96 by r square. Now, so of course we know that, see, they have given area of sector. So area of sector, we know that the formula is half into r square into theta, right? We need to find what? We need to find the angle theta, right? And they have given area of sector. Area of sector is how much? It is 48 centimeters square, right? So we'll use this thing. So we'll get 48 is equals to half into r square into theta. So I'll just move this 2 there, r square here. So I'll get theta is equals to 48 times 2, which is 96 by r square. That's the first part. Now let's talk about the second one. Given that the minor arc AB has length 12 centimeter, okay, so they have given that the length of arc is 12 centimeter, find the value of r and of theta, okay. So they have given, they are asking you to find the value of r and theta, and they have given length of minor arc is 12 centimeter. So we know that length of arc is what? It's going to be r into theta, right? They have given length of r, like we know the formula, that is r into theta. So, and they have given that the length is 12 centimeters. So basically 12 is going to be your r into theta, right? Now we have already calculated an equation with respect to theta and r square. Let's say this is equation 1. And from here also we can get theta is equals to 12 by r, which is equation 2. What I'll do, I'll just substitute here and there, and let's figure out the value. So we'll just substitute 12 by r in this theta. So what we will get? We'll get 12 by r is equals to 96 by r square, right? And then we'll solve here and there. We cannot like r cannot be 0, that's why we can cancel. Otherwise, let's use quadratic thing only. So that's why even r we can cancel, because r cannot be 0, that's why we can cancel. So we'll just cancel this square with this r. So we'll get 12r is equals to 96, or r is equals to how much? It's going to be 96. So it's going to be 96 by 12, sorry, which is nothing but 6, 7, 8. R is equals to 8 centimeter. So that's going to be the radius of the circle. Now they are asking theta also. So theta is going to be how much? Theta is going to be, we can use from here, which is going to be 12 by r, which is 12 by 8, which is nothing but 3 by 2 radians. Now see, of course we are using all the formula with respect to radians. That's why the theta is going to be 3 by 2 radians. Okay, just a second. Yeah. Okay, using the values of r and theta, find the area of the shaded region. Oh, okay, now this is important. Now see, area of shaded region we need to find. So as you can see here, this is your OAB, whatever this thing, this is the whole sector. So the shaded region is this part, like obviously it's shaded, that's why. So it's going to be what? It's going to be area of sector minus area of triangle. Now see, I told you that that sine rule will be used. I mean that area of triangle, that thing. So it will be used. So that's why here we are going to use. So area of sector is going to be what? It's going to be half. Acha, we already used that thing, na? Area of sector half into r square theta. So we already know it's basically how much? 48. So we'll use that thing. So 48 minus area of triangle. Now area of triangle is going to be what? It's going to be half into side into side. So this side into this side, which is r into r. So that's going to be half into r square into sine of angle between them. So sine of theta, which is 3 by 2. And don't, sine of 3 by 2, whatever the value is going to be. Now, just a second. So it's going to be what? It's going to be 48 minus half into r square. Radius was how much? Radius was 8. So that's why 8 into 8, that's why 64 into sine of 1.5, which you can put it in the calculator. So you will get 48 minus 32 times sine of 1.5 is nothing but 0.997. So 0.997. Just to see that. Which is going to be 48 minus 31.904. And that is going to be how much? That is going to be 16.096. Yeah, that's what your answer is going to be. Okay, so this is how we got 16.096. Now, let's try some other question. So, let's do this. Question number 6. And this was asked in May, June 2018. Anyways, now, in the diagram, AOB and DOC are sectors of a circle center O. The angle AOB is x radians. The length of the arc AB is 40 centimeter. And the radius OB is 16 centimeter. Find the value of x. Now see, they have given the arc length and they have given the radius. They are asking you to find the angle. So we know that length of arc is nothing but r theta. So they have given length of arc is 40 centimeter and radius is 16. So 16 into theta. So theta is going to be 40 by 16, which is nothing but 5 by 2 radian. So theta is basically 5 by 2 radians. Now, find the area of sector AOB. So area of sector is simple. Area of sector is going to be half into r square into theta. So here it's going to be half into radius is how much? 16. So 16 square into theta, which is we just found that is 5 by 2 radian. So which is nothing but 4 into 16, 64 into, oh, what am I doing? Yeah, 64 into 5. Yeah. Which is how much? Which is 320 centimeters square. That's going to be the area of sector. Now, given that the area of the shaded region ABCD is 140 centimeters square, find the length of OC. That means what? They are just asking you to find the inner radius of the circle, of the sector, whatever. Now, area of shaded region is going to be what? Area of shaded region will be area of that AOB, area of sector AOB minus area of sector DOC. Now, area of shaded region they have given already, which is 140 centimeters square. Oh, it's here. 140 centimeters square. And area of AOB we already found, which is 320. So 320 minus area of DOC. So area of DOC. So basically we got area of DOC is nothing but 320 minus 140, which is nothing but 180 centimeters square. Now that is area of sector DOC. Now of course we can put the formula and also we know the angle as well. So we will just put it. So it's going to be half into r square. R square is what we need to find. So half into r square into theta, which is how much? 5 by 2. So into 5 by 2 is equals to 180. So this is nothing but r square is going to be 180 times 2 upon 5. 1 and this is going to be 36. So at the end r is going to be square root of 36 into 2 into 2, which is nothing but square root of 36 is 6 into square root of 2 into 2, which is 2. So the answer is 12 centimeters. That's going to be radius or the length of OC. So OC is basically 12 centimeters. Now let's take some recent problem which was asked in 2020. Yeah, this one. Yeah, okay. So this question, so let's start with this thing now. Let's start with this question number 3 now. So I'm taking just random questions. So this was asked in May 20. So let's start with this thing. A circle has a radius of, can you see it? Yeah, a circle has a radius of 6 centimeters. So we'll just put r is equals to 6 centimeter. A sector of the circle has a perimeter of 2 times 6 plus 5 pi. Now, a sector of the circle has a perimeter of 2 times 6 plus 5 pi. Now people will get confused here. Now see, here they have given that the perimeter of the sector is 2, 6 plus 5, whatever the value is. Now see, the perimeter of the sector is not going to be just this much. This is length of arc. The perimeter is going to be including this r as well as this r. So if you see, the perimeter will be r plus length of arc. So it's going to be 2r plus length of arc, which they have given as 2 times 6 plus 5 pi. They are asking you to find the area of the sector. Now, for area of sector, we need radius as well as we need theta, I mean the radian. So radius they have already given, which is 6. Right, so basically we need that angle theta, which we will find from this thing. So perimeter is how much? 2 times 6 plus 5 pi, okay, whatever it is equals to 2r. So 2 times 6 plus length of arc is going to be how much? Length of arc is going to be r into theta, and r is how much? R is 6, so 6 theta. So as you can see, this is going to be 2 into 6, so 12 plus 10 pi is equals to 12 plus 6 theta. Can cancel this 12 with this 12, so we'll get theta is equals to 10 pi by 6, which is nothing but, theta is nothing but 5 pi by 3. Okay, that is going to be the theta. Now they are asking what? They are asking area of sector as well, sorry. So area of sector is going to be what? Area of sector is going to be half into r square into theta. So it's going to be half into r is nothing but 6. So that's why 36 into theta. Theta is nothing but 5 pi by 3. So see, if 2, 1, this is 18 and this is 3, this is 6. So the answer is 30 pi centimeter square. Of course, you can multiply by pi and you can calculate those things. Now, okay. Now let's start the part B of this question. Now, as you can see here, we have the sector which is OAB. So the diagram shows the sector AOB of a circle with center O and radius 7 centimeter. Angle AOB is pi by 4, like this angle. Find the perimeter of the shaded region. So now, as you can see, the shaded region is this. Like, you need to find the perimeter, right? So we are going to use length of arc and all. So it's going to be what? Just a second. Yeah, it's going to be. Yeah, it's going to be this AB and this AB segment as well. Now see, this AB is very easy to find. So it's going to be what? It's going to be just length of arc, which is nothing but r theta, which is r is how much? R is 7 centimeters. So 7 into pi, which is pi by 4 radians. So the answer is going to be 7 into pi by 4. Now see, here r is given as 7. So of course we know that pi is nothing but 22 by 7. So we can write this thing as 7 into 22 by 7 into 1 by 4. And we can cancel this 7 with this 7. So we'll get what? We'll get 11 by 2. Now that's the length of AB, like the curved one. Now to find this length AB, just a second. Now to find like this length AB, so what we will do, we'll just observe this triangle OAB. Now see, it's an isosceles triangle, right? Now what is the property of isosceles triangle? If I make a point like this and a perpendicular from this to this, like this, then this is going to be the midpoint. Let's say this is M. Wait, I'll just change the color. Now, if I know this is M, like this midpoint, so let's concentrate on this triangle. Now, as you can see here, hypotenuse is 7 centimeter. This is pi by 4. Of course, this angle is going to be bisected. And this angle is going to be how much? This angle is going to be pi by 8. So now we can say that this side AM is nothing but hypotenuse, that is 7 into its opposite to it. That's why it's going to be sine of pi by 8. So that's how the length of like this AM is going to be. Now of course AM and MB are equal, so the total length AB is going to be what? So the total length AB is going to be twice 7 sine pi by 8, which is nothing but 14 sine pi by 8. Now that's the value of the segment AB. So now to find the whole region, shaded region, so it's going to be what? It's going to be 11 by 2 plus 14 sine pi by 8. Now that's your answer. So of course you can use calculator to find the value. That's not a problem. Okay. So we have done like how many 3-4 problems based on this thing. I hope you got the concept so that we can apply. If you feel like that I should do more problems based on this thing on past papers, so yes, I can definitely do that. Make sure to comment on that and let me know which type of videos you need or which type of revision lecture we are going to do. So the next video I'm going to do will be based on trigonometry. Okay, so we're going to start with trigonometry from unit circle, further trigonometry, everything we're going to do. So if you like the video, then like it and stay updated by subscribing the channel. Okay, then I'll see you.